As I record this, it is evening here, so it's good evening to you. Welcome to the course STAC33. My name is Ken Butler. I'm a assistant professor teaching stream at U of T Scarborough, and one of the things I like is applied statistics using software and coming to conclusions from data, from real data. And that's what this course is more or less about. So let me take you through the course outline that we have here and explain some of the things that I will be expecting and some of the procedures that we'll be following. And I'm a little bit too big, so I'm going to move myself over there. Okay, there we go. So this is an online course, as is the way of things these days. And the way I've chosen to structure it is that I'm going to record some lectures like this, so you will see my face and you will see slides, or you will see RStudio and doing things in RStudio. And I will record them ahead of time and you can watch them when you choose. Asynchronous is the fancy word. So that's the basic structure of the course. I will record 2 to 3 hours of lectures per week, and you can watch them as you wish. There's also going to be 1 hour of live tutorial a week. That's on Monday morning. You have a tutorial time, 1 hour during that period. And that will be organized by our TAs. We have 5 TAs. And there should be 2 TAs for each tutorial. And I may pop in from time to time. That's on Zoom. We will pass you on the address when that's available. And also, if you need to see me at some point, you can arrange for office hours with me also on Zoom, and I ask you to make an appointment for that. Alright, some stuff about me. There's my email address there. And what I like doing is sharing what I know about applied statistics and what I know about R particularly. I mentioned here, before I forget, that sometimes we do SAS as well in this course, and I'm not going to do SAS this time because we have plenty enough to do in R. I have a link which I'll share with you later for some SAS materials of mine, which you can work through if you wish to. So, the aim of the course is to help you develop the skills to use software to analyze data and to communicate the results. And I make that point right off the top because it's all very well being able to analyze data, but if you cannot tell people what you found and why it's interesting and why it's important, then you are not an applied statistician. You are somebody who lives in a back room and doesn't know how to communicate. So communication is key. A lot of my questions you will see have the words "explain briefly" attached to them, and I want you to say something about how it is that you know what you do is the right thing to do. In other words, can you justify yourself? In the same way, really, that even though this is not a math course, in math there is a right answer because you can prove a theorem or you cannot, but hidden in that is there are different ways to do the proof, some of which are more logically sound than others. And the same kind of principle applies here. There are many different ways in which you can analyze a certain data set, but you have to find a way that's convincing, and you have to convince other people that what you have done is reasonable. So that's why effective communication is key, and that's why we're going to be doing that in this course too. And what I want you to demonstrate is your understanding and your insight about the data you're working with. Not just to get an answer, but to get an answer for a good reason. And I will help you to work towards this, which appears to be half off the bottom of the screen. So it is. Alright, now I'm definitely in the way here, so I'm going to move myself over here. I'm going to move myself over there. Alright, now I'm looking at you from the other side. What do you need? Oh, I'm a bit too high here. I need to be down a bit. There we go. You need a second statistics course that covers statistical inference. And the course I'm thinking of is STATS B57. And if you happen to be coming from St. George, then I expect a St. George course that covers the same kind of ground, STAT 248 or STAT 261. I check prerequisites, and if you don't have something that I consider appropriate for this course, then I won't let you stay because you have to have a prerequisite. The other thing I mentioned is if you're in one of the Scarborough Stats Program's minor major specialists, you will actually need specifically the course Stat B57. So having that already is a worthwhile thing. Alright, how are you going to get help if you have problems? There are 3 options that I've thrown at you here. Number 1, come to the tutorial and ask the TA when the TA asks for questions. Option 2, use the discussion board on Quirkus, ask your question there. If you have an answer to a question that somebody else has asked, then go ahead and post that too. I mention this because this is a big class, there's 240 or thereabouts of you. And I don't want to be answering the same question multiple times. Excuse me. So what I would like you to do is to post your question on the Quirkus discussion board, and then it can be answered for the benefit of everybody. If it's a question of course procedures, then you can look in this document first. This is linked on the website, which we'll come to shortly. And if you don't see it there, stick it on the discussion board. If it's a question about the material, then certainly you can go ahead and ask it there. If you really need to get hold of me, I'm willing to meet other times on Zoom. Make an appointment, send me an email. And if you have an issue that's more personal, you're willing to deal with over email, that will work as well. If it's something about you, not necessarily about the course as a whole. So you have a number of options for getting help. I feel like I should say this, so I'm going to say this. Here's how to write an email to me in a way that increases your chances of getting an answer that will actually help you. So, first off, use the U of T email so I know who you are. Use the subject heading so I can find it when I come to reply to it. Address me as Dr. Butler, if you would please. And the clearer you can state how I can help you, and the quicker I can figure this out, the better your chances of a quick reply. It might be as quick as immediately, and if it takes me time to work out what you want, it might be a bit longer than that, if at all. Please include your name, as U of T knows it, and your student number. And the reason for your student number is in case I have to look up which courses you have previously taken or anything like that, then I will need to know that. So, here is my aim, 1 working day, but there's a lot of you, and if I get a lot of email, it will take longer. So, I have hinted at some of these things course objective-wise. The immediate number 1 thing is to use software, namely R, to analyze data and to communicate what you found, the second thing. And I'm going to give you an assignment, a fairly small one, every week. Some of the questions on the assignments ask for output, code and output from R. Some of them ask you to explain what the output means. And as I mentioned before, the grading will reward evidence of clear understanding and insight, because that's what I want. What you will learn along the way, in fact, in tutorial 1 in week 2, is how to use R notebooks and how to turn those into reports in HTML or PDF or anything like that can be read by somebody else, like, for example, your grader. Alright, some course materials. First thing on each line is a link, even though it doesn't look like a link. The first one is Quirkus. I will put the lecture videos up there, and there are some there already. And this is where you'll hand in assignments. Oh, I didn't mean projects. We don't have projects in this course. Hand in assignments, receive your grades and your comments from the grader. We also have a course website. And I guess I can show that to you. Let's see if I can link to that properly. Here we go. This is the course website with another bad picture of me. There's a sort of historical thing about this, which is this is actually my office on campus, and I haven't been there for about 2 months, and I've been there like twice in the last year, pretty much, since this all blew up. So it's kind of strange to have a bad picture of me in my office when I'm going to be spending all my time at home, but so it is. That's the nature of it. And this is the latest news and some stuff about what if you're on the wait list and some other things. And there's some links at the top, including lecture notes, a link to Quirkus, and a link to past tests, which I'll explain in a minute, some old exams which are of no great relevance to you, and some other things about me. What you'll probably want here is this news feed and the lecture notes. Those are probably the things you'll want most frequently from here. So that's the website. I think we can get rid of that. Let's go back to where we were, which was here. One of the links was a thing called PASIAS, which stands for Problems and Solutions in Applied Statistics. So let me see if I can show you that. This is a collection, literally, of problems and solutions in applied statistics based on previous homework assignments from this course and courses like it. And there's a number of chapters, and there's a number of problems within each chapter. So here's the introductions and packages used elsewhere, and getting used to R&R Studio. We start right from the beginning, and things like reading in data and drawing some graphs. And I will refer you to problems in here as problems you can practice with. You can work through these, see what I did, see what you would have done. And that will give you a sense of how to tackle the assignment problems when they come your way. There's a couple of other things. Let's move me out of the way again. I need to be over here. There we go. Computer requirements. This is actually a link, as you can see there in the black. This is actually a link to the Vice Provost of Students website, and that has general computer requirements for courses. And for tutorials, since they're on Zoom, you'll probably want a working camera and a microphone so you can talk and be heard. We're going to be using R. We're going to be using R and R Studio. And I'm going to show you all about installing that and using it. There's actually two ways you can do that. One way is to use rstudio.cloud, which is actually web-based. And so all you need for that is a web browser. And that is free, at least for a little while. You might run out of the free tier. If you happen to either have or want to install R and R Studio on your computer, then that of course is completely free and you don't have to worry about that. That's a little bit more work. If you've already done that, then feel free to use it for this course, for another course. I would, if you're starting from new here, I would start with rstudio.cloud, and after a little while, once you've got used to that, think about installing R and R Studio on your computer. There are instructions in the lecture notes. You just have to follow the instructions. Last thing here is a reference book, which is actually free. Also, it's a book and it's also a website. Here it is. This is what the book looks like. It's with the red New Zealand bird on the cover, which is with the red. And because the author of this book, Hadley Wickham, is from New Zealand, all of his animals on the pictures of his books are from New Zealand as well. So this is a kakapo, I think, which is a New Zealand bird. So this is the website for the book, and this provides a lot more background about the things that we're going to be doing, some of them at least, and a lot more detail about some of those things, which will help you understand why things are as the way they are. This is background. We don't use this specifically in this course, but it's good background, and if you want to explore things further, this is a good place to start. Alright, am I out of the way? Near enough. Okay. So that's talked about all of those things. Alright, how am I going to assess you? Well, the immediate thing is no exams. You may cheer now if you wish to cheer now. What we'll be doing is we'll be having weekly assignments. There's going to be 10 of those in weeks 3 through 12. And what I wanted to do is, because things are unpredictable in these times, I didn't want you to have to do all of those. So what I'm going to do is I'm automatically going to count the best 8 out of those 10 assignments. And the 8 that count are worth 12.5% each. So it's a very simple grading scheme. There's no exams, there's no projects, that's all the grading scheme is. And they will be available on Tuesday of each week and due on Thursday at 1 minute to midnight. And they're based on the previous week's recorded lectures. Now, when there was actual in-person instruction happening, what we had 1 hour of lecture on each of Tuesday and Thursday. And the tutorials were on Monday like they are now. They were in a computer lab. And so I will try and label lectures Tuesday and Thursday when I record them, so you know where you stand. But there will be 2 or maybe a bit more than 2 hours per week. And 1 week's recorded lectures are the next week's assignment, and in between the lectures and the assignment being due, you have a tutorial on Monday. So there's where you can find out what's going on. You can think about, what am I having trouble with? You might get some more insight from the TA. And the way I do assignments is I give you a certain amount of time between the time you open it and the time you need to have handed it in. And 3 hours is an example. I might give you more, depending on how long I think the assignment is. It's meant to be long enough for you to do it, looking a few things up along the way, but you'll need to know roughly what you're doing. And I want to make an important point, which I'll make right here, which is that the assignments are really serving as mini take-home exams. And so I'm not going to offer you help on the assignments themselves. Don't ask and don't expect to get help. You're on your own when it comes to doing those. The time to get help is on Monday in your tutorial, or by working through the practice problems that go with each lecture from past years. So that's the place to get help. And then by the time you get to the actual assignment, you should be understanding things reasonably well and ready to go on your own. Now, the grading scale might be a little bit unfamiliar to you, so I'm going to explain that too. Because maybe you're used to doing things and getting the right answer, and when the right answer is there, you get full marks. And applied statistics is not like that. Applied statistics is not about getting the right answer, it's getting one of the sensible answers. There could be several. And it's about the process. Are you getting a decent answer for a decent reason? One that is convincing to somebody reading your work. And so the marking scheme reflects that. So if you provide good explanations demonstrating clear understanding, that's where the high marks will come from. If you just give an answer and you give no explanation at all, well, that's going to be worth about 6. So you want to be thinking about using your language skills to justify the work that you have done. That's the grading scheme. So the average will be somewhere between 7 and 8 probably. And this is based on a scheme called standards-based grading. And so we have a notion of what is acceptable work in the back of our minds, which would be an 8. And the idea is that after your work is handed in, you'll get some feedback on it, and that feedback is something you can use to improve your work on the next assignment. So you'll know something about what was missing, something about what could have been done differently or better. And there is a certain subjectivity to this, because there is a certain subjectivity to applied statistics as a whole. And the grades are the grader's best judgment of your work, so don't expect them to change if you think they're too low. And what I like to do is I like to give all of you my detailed solutions, in which I explain some of the various possibilities and some extra things I thought about. So that's why I use the word detailed. And they'll be available after each assignment is handed in, which means you better hand these things in on time, or else you might be too late. So, that last point is the first point here. I want to post my solutions for everyone to learn from. So I want to do that as soon as I can, which means I don't want to be waiting around for people to hand their work in. I'm willing to be a little bit flexible about lateness, like a few minutes. But if you hand it in after my solutions have been posted, you're out of luck. Now I mentioned back at the beginning, I need tea here, tea. I mentioned back at the beginning that you have 10 assignments and the best 8 of them count. And what that means is that you can miss completely 2 of the assignments. I call them 2 free assignments. You can not do them at all if you want to. And no one's going to ask you why you didn't do them. That's entirely up to you. You can miss them without explanation, without warning. And so, as long as you can do 8 assignments out of the 10 altogether, then you'll get your grade, and your grade will reflect your work. If it so happens that things are more difficult for you, if there's something beyond your control that makes it impossible to hand in even as much work as 8 out of 10 assignments, let me know and we'll see what we can work out. But do that before the first of those assignments are due, so we can make plans. And especially with a course as big as this, we're not doing make-up assessments. If you miss it, you miss it. And given what happened almost a year ago, I ought to put the last point in, which is that things may change during the semester. None of us has any idea what's going to happen. And so, if we need to change things around, I will change things around. If I need to take a class vote, I will do that if I need to. So that is there just in case. I hope we'll be able to get through the semester and everybody can do their 10 assignments and get the best 8 counted and everything will be fine. But things don't always work as smoothly as that. Alright, what are we going to be talking about? I'll go through this in a small amount of detail, just so you can get an idea. The first thing, which we'll be doing in the first week of classes, so that will be coming up on Tuesday and maybe Thursday, probably Tuesday, is how to actually install or connect to R and R Studio so we can actually use them to do things. So as I say, I'm starting from the very beginning. If you already know how to use R and R Studio, then this will not be new to you at all. But if you're coming to this from nothing, which is fine, then we'll start you from the very beginning. So there's basically 2 flavors of it. I think I mentioned before RStudio.cloud, which is online. Sorry, I said that too fast. RStudio.cloud, which is online, and that is a web browser only. Or you can install R and R Studio on your own computer, and that's what I would recommend eventually. But the details of that are in the first week's lecture notes, and you'll see those. Then we talk about reading in data files of different kinds, of different ways to do it. Then we get into some fun business of making graphs and thinking about what kind of graphs are the right kind of graphs for our data and the conclusions we want. Then we talk about numerical summaries, and I need some more tea. And then we're going to go through in some detail, because it seems to be helpful, statistical inference. So start from one sample t-tests and confidence intervals and go through to analysis of variance and the various flavors of that. And we'll talk about writing reports, and I'll give you on one of the assignments some practice at writing a report. And then we get into data wrangling. I've got some stuff on tidying and organizing data, which is actually something that you, as an employed statistician, will spend an enormous amount of your time doing. So I really wanted to have that in this course. Then we have a couple of case studies which are based on regression. So you'll see some regression ideas. And then we've got some more programming type things. Functions are, as you may have seen in Python, a way of encapsulating a big idea into a small package, so that when you have this idea of I want to do this, which is long, you can write a function to do it all, and then call that function as many times as you need, or a repeated task. Another thing that's interesting, and one that you'll run into, is dates and times, and they are awkward to deal with unless you have some practice. And there is an R package called Lubridate, which is very helpful in dealing with those. I've got a miscellania of tasks in R that seems to fit right there. I can also show you how to do vector and matrix algebra in R, using matrices, using vectors, as if you were doing A22 or something like that. And then two statistical things. The bootstrap, which is a way of making inferences when you don't trust normal distributions, or is another way of looking at it is to say, can I trust the inferences that I did? And this all goes back to the central limit theorem and are my data normal enough, which are themes that we approach at various times. And there is some talk about the bootstrap and some embellishments of that we'll deal with there. I might move some of the bootstrap stuff earlier because it's actually interesting even when we come to do a t-test. We want to think about, are my data normal enough? And there are some issues there which are kind of hard to reconcile. The last thing is the bit where there's actually a teeny bit of mathematics, is doing Bayesian statistics as you saw in B52 or B57, wherever it was. And there is an R package called RSTAN, which is a kind of a mini programming language all by itself, in which you can set up things to sort out prior and posterior distributions to do Bayesian statistics without needing any math. And that's actually rather interesting. We'll come to that at the end. So I'm not quite sure. I think it's a little bit too much work here for 12 weeks, but we'll see how much of that we can get in. Alright, if you need accessibility help, then make sure you get it. Please, if you have things that will help you succeed in this course that can be documented, work with the Accessibility Services Office, and they will give you accommodations as they deem appropriate. Alright, last 3 pages are expectations. I think they're expectations of me for you, but anyway. First thing is, I expect you will do your own work in this course and not seek help from outside the course. You can get plenty of help from me, from the TAs, from doing problems. So there's all the stuff you need in this course is within this course. You do not need to look elsewhere. And if you do something which is not as things are done in this course, you can expect some consequences. And I mention here that the chair's designate for academic integrity is investigating an issue from my fall course. So if I need to do the paperwork to get these things followed up, I will. So all the ideas you need are contained in the lecture notes, with a few exceptions which I'll tell you about when they come up. But otherwise, seeking help from outside the course may end up confusing you more than it helps you. So it's not really a very good idea. Alright. Anything that's in the lecture notes, in past years, in solutions to previous assignments, or from conversations with anybody within the course, that's all fair game. You can use any of that. If you look up something on the internet, or if you get some help from someone else, you've got to say where the thing you found came from. And here's a way of doing that according to this website, and then say wherever it is you learned. If you learned something in another course which you might have done, then say which course it was. But what you need to be aware of is that things might be done differently in other courses. See the first point on the next page, which I will see right now. I expect you to learn how to do things as they are done in this course. There's no point you doing this course if you're going to do things as you do as they will be done elsewhere. I think my way of doing things is generally better and clearer, as I will explain as we go through. In any case, if it's not from this course, say where it came from if you expect to get any credit for it. And there is an equity issue here. The reason why academics cite their sources is that you want to acknowledge somebody else's point of view. You want to make sure that people get credit for ideas that are theirs. You don't want to make out as if it's you thought of it when you didn't, when you got it from somewhere else. And not citing a source when you should is a way of erasing someone's point of view. And I don't think you would like that if it happened to you, so don't do it to other people. Alright, so that's why I expect you to do things as they are done in this course. And there's really no reason not to, because all the material you need is in this course. If you're having trouble, tell me. I'm not going to judge you or think less of you. And I hope the same applies in reverse. This actually came from somewhere else, which I think I will show you, because it's actually rather good. This is from a chap called Andrew Heiss, and he has a rather nice syllabus for his economics course. And he has all sorts of things like that. You can read that if you want to, there's a link there. Final thing, I am doing my best to give you an opportunity to learn something that will directly help you in your future. If you're going to be working as a statistician, you are going to be dealing with data sets in all their ugliness all the time. And so the stuff you learn in this course will be stuff that you can apply directly. As long as you learn it, I'm giving you an opportunity to learn it. If you don't learn it properly here, then you're not going to be much of a statistician to be employed by somebody else. So, I'm doing my best to give you this opportunity to learn something that will be helpful, and I would like for you to take that opportunity. Alright, that's it for tonight.